show that the surface area of a closed cuboid is a rectangular prism, okay?
Okay.
Closed cuboid with square base and given volume is minimum when it is a cube. When it is a cube. So we have a rectangular prism,
Mm-hmm.
and we have to show that its surface area will be minimum. So this is a question of optimization when it is a cube. Okay.
Mm-hmm.
So if it helps, you can draw a rectangular prism. Okay, remember that a cuboid means a rectangular prism.
Okay.
And it has a square base. So its base is a square. Okay.
Mm-hmm.
Okay, so let's say this is a rectangular prism. Its base is a square, so the length and height you can take same,
Mm-hmm.
and this is the width. So now we don't have any variables, right? We'll have
Okay.
to assign the variables.
Okay.
And volume is given, so that is fixed.
Mm-hmm.
Assign the variable v, and surface area is minimum. So surface area, we'll have to create a function for surface area.
Okay.
Okay, and then we have to take length, width, and height. So height and length we can take x, and this thing we can take y.
Mm-hmm.
Okay, so what will be the volume? Volume of rectangular prism?
X squared y.
X squared y. So V is x squared y.
Mm-hmm.
And V is a constant
Okay.
because of this word, given.
Okay.
Given volume means volume is fixed, it is constant. We can treat V as a constant.
Okay.
Okay. Then we'll need to create a function for surface area.
Mm-hmm.
Okay, so surface area will be how much? Areas of all the surfaces.
Mm-hmm. I think it's 2x squared plus 4xy.
Yeah, 4xy. Okay, so right now our function S,
Mm-hmm.
it's a multivariable function. It is a function of both x and y,
Mm-hmm.
but we need it to be function of only one variable so that we can differentiate it.
Okay. So we would use the volume function to make it into one variable?
Yes. So
Okay.
from here, we'll have to find out the value of either x or y.
Okay.
And I think it will be easier to find out y. So y will be equal to v over x squared. Because if you try to find out x, you'll get.
There'll be square root and yeah.
So now we can put the value of y in this
Mhm.
equation. So s is equal to 2x squared plus 4x times v over x squared. And v is a constant, so we don't have to worry about it. So now we have a function s of x, 2x squared plus, this gets cancelled, 4v over x. And we have to minimize the volume.
Mm-hmm.
Sorry, we have to minimize the surface area.
Mm-hmm.
Okay. So obviously we'll need to differentiate the surface area function with respect to x.
Okay.
So d over dx of s of x.
So it'll be 4x plus 4 times v over x squared plus,
Minus,
sorry?
minus 4v over x squared, because this is 1 over x, which is x raised to minus 1. Derivative of 1 over x.
You multiplied it? Oh, okay, okay. I thought we were supposed to use product rule, but okay. That makes sense.
4v is a constant, so you can ignore 4v.
Okay.
Just see there is 1 over x, and derivative of 1 over x is negative 1 over x squared. So we'll get minus 4v over x squared.
Oh, okay, got it. Okay.
And now for minimum or maximum value, we need this thing equal to 0
Equals 0. Okay.
for minimum or maximum value.
Mm-hmm.
Okay, so 4x minus 4v over x squared equals to 0.
Mm-hmm.
You can factor out 4. X minus v over x squared equals to 0. Then x should be equal to v over x squared. And remember what we are trying to prove? We are trying to prove that any rectangular prism whose surface area is minimum, that will happen only when it is a cube.
Oh, okay.
Okay. So if you simplify this, you'll get v is equal to
X cubed.
x cube.
Okay.
Okay. So v is equal to x cube. Well, from here, it is provable that you can prove that if v is equal to x cube, there are chances that it is a cube, but we'll have to verify it.
Okay.
Because volume of x cube means x times x times x, which is the formula of volume of cube. But we'll verify it by using the second derivative test or the sign analysis.
Okay.
Okay, so we need to find out the value of x. So
So
volume of
x is cube root of v?
no, we'll have to find out the value of x in terms of y.
Oh, okay.
So you remember v was volume was x square y. So we'll put x square y here. From here, if you solve for x, this will get cancelled, and here you'll have only one x. So x is equal to y. This. And now we can do the sign analysis or the second derivative test. Okay, x is equal to y. Okay, so we'll check the sign of ds by dx in both the intervals. ds by dx was 4x minus 4v over x squared. So how will you check the sign of ds by dx?
If we don't have values, how would we do that?
Exactly. So you can assume that, so any value which is in this interval, in the left interval, that will be less than y. Here x is less than y. Okay. So you'll have to check what will happen if you take a value which is less than y. Here, what will happen? So 4x minus 4 times. First of all, this x square and x square will get cancelled.
Yes.
You have 4x minus 4y. Now, if in place of x, you're taking a value which is less than y. Here you have x. You can also factor out 4. You'll get x minus y. And now you'll have to do the analysis that if x is a value which is less than y, so this quantity will be negative. I mean x minus y. And you're taking value of x which is less than y.
Mm-hmm.
So x minus y will be less than 0 for x less than y. Okay.
Mm-hmm.
So this interval, all the quantities here will be negative. And if you take a quantity in this interval, that means any quantity x which is greater than y. So in that case, 4 times x minus y. So x minus y should be greater than 0 for x greater than y, right?
Mm-hmm.
Okay, so this interval will be positive.
Okay.
Okay, so
That
that,
does show a minimum.
hmm, that means before y values, the function is decreasing. And
Decreasing.
after this value, the function starts increasing. So that
Yes.
this is a point of minima.
Mm-hmm. I think normally if you had given me a question like that, I would not be able to like do the sign analysis.
Yes, usually it's not necessary to do the sign analysis. You can also show the minimum or maximum value by doing the double derivative test. And I think in your AP exam, you can use double derivative test.
Oh, okay. If you had used the double derivative test, what would it have been like?
So then you find out the second derivative of s
Mm-hmm.
d2s over dx square. Okay, so this was the first derivative. This was the first derivative. Again, we'll have to differentiate it with respect to x. So you get 4 plus derivative of 1 over x square will give you negative 1 over x cubed. So negative negative becomes positive.
Uh-huh.
And 2 will come in front. So 2 times 4 will be 8. So 8v over x cubed.
Mm-hmm.
Okay. And you just have to check that at this point, this is a candidate, right? X
Yeah.
is equal to y. That's a candidate. So at this candidate, what
Mm-hmm.
is the sign of d2s over dx square?
Oh,
X
okay.
is equal to y. So you need to check the sign of this. So 4 plus 8v over, in place of x, put y. So y.
Okay.
And you can also put the value of v. It was x square y.
Mm-hmm.
So 4 plus 8 times x squared times y all over y cube. So y, this becomes y square.
Mm-hmm.
X square and y square, they will again get cancelled because x is equal to y. So 4 plus 8 times y square over y square, because x is equal to y. Y
Yes.
square and y square gets cancelled. So you get 4 plus 8, which is 12, which is greater than 0. So whenever our double derivative is greater than 0, then that candidate is a point of minima.
Okay.
So x is equal to y is minima. 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 Okay, so that means that the surface area will be
Mm-hmm.
minimum when x is equal to y.
Okay.
So that means we had taken two variables, x and y. Now this y is also equal to x. So basically this will become a cube.
Okay.
So if you can reduce the length, and this will become a cube.
Okay.
Okay. And questions of optimization will be like this. Oh, did you write everything?
I'm writing it down right now.
Okay.
Mm-hmm.
So next, let's take. So we have a square piece
Mm-hmm.
of side 24 centimeters is to be made into a box without top by cutting a square from each corner
Mm-hmm.
and folding up the flaps. Folding up the flaps to form a box.
Okay.
Okay, to form a box. So what should be the side of what should be the side of the square to be cut off? Side of the square to be cut off so that the volume of the box is maximum.
Okay.
To have maximum volume. Okay. And also we have to find the maximum volume. Find the maximum volume. Okay, so we have a square piece
Mm-hmm.
of side 24 centimeters. We have to cut it and we have to make a box. And from top, it will be open.
Okay. Okay.
Okay, so first of all, let's take a square piece.
Mm-hmm.
This is 24 centimeters. And out of this square piece, we have to cut flaps by cutting square from each corner. Okay, from
So
each corner.
square is going to be cut off from each corner.
Yes.
Okay.
And then when you cut the square piece, you can remove the square piece. Then whatever will be left, those will be the flaps.
Yes, I've seen this problem before. Or something similar to it. I've seen the model.
Okay. So let's say these are the square pieces. So we need to identify what should be the side of the square. So what should be the side of the square
Mm-hmm.
to cut so that the box has the maximum volume. Okay, so you can see these flaps, these
Yes.
rectangular flaps. And these pieces will be gone, square pieces. Okay, so you want to maximize the volume. So now you identify, so imagine that this problem is in an FRQ. So
Uh-huh.
how will you approach? What variables should we take? Which function to define?
Do you mind scrolling up a tiny bit so I can read it all once again?
Yes.
Thank you. Um, corner, which should be the side of the square to be cut off to have the max volume. Okay. Mm, okay, so I think for it to have the max volume, so volume of the cube will just be x cubed, right?
Uh, which cube?
The cube inside that.
But we won't get any cube. We will
Oh, you're right. The top is off. You're right. Okay.
chop this off and
So it would be 4x squared for the volume for the area of the squares that are cut off.
4x squared. Oh, okay. Okay. So you're taking the size as x, size of the square.
Mm-hmm.
Okay. Then area of all the four squares will be 4x squared. Okay.
And
Area of all the squares cut off.
yes.
Okay.
And then something minus 4x squared is the actual. Actually, no. Um, I'm not sure what to do next.
Okay, so in these questions, how do we approach these type of questions? Always we will try to create a function
Uh-huh.
for that quantity which has to be optimized. These problems, they are called optimization problem. So in these problems, you will always see there will be a quantity which has to be optimized. Now, optimize means either it has to be something has to be minimized or
Mm-hmm.
maximized. So first identify which quantity here needs to be optimized.
The volume of the cube inside.
Volume of the box.
Yes. Sorry.
What It's okay. So what should be the side of the square to be cut off to have maximum volume? So when you will fold these flaps, this one, two, three,
Mm-hmm.
four, you fold
Mm-hmm.
these flaps from the sides. So you'll kind of have a box where, you can put stuff inside that box, but it will be
Yes.
open
Yes.
from the top. So we
Yes.
have
Yes.
to maximize the volume of this box. So first step, we'll try to create a function for this quantity, for the volume of the box.
Okay.
And now, of course, obviously, when you want to find out the volume of this box, you need all the dimensions.
Mm-hmm.
Okay, so volume of this will be a cuboid or a rectangular prism.
Mm-hmm.
So what is the volume of rectangular prism?
X
Length?
squared y.
No, no, no,
Length
no.
times width times
The height.
height.
Yes.
Okay.
Length times width times height.
Mm-hmm.
Okay. Now, what is the length, width, and height? You have a net. You remember in geometry, you would have done questions of 3D shapes in which you used to have some objects and then we used to create their net.
A
3D.
net. Yes, I think so. Yes.
So right now, what you actually have is a net, and we are trying to imagine that we'll close this, the flaps of the net.
Uh
So
huh.
what will we get, right? So
Yeah.
just try to identify the length, width, and height of this box that we'll have. So you can take this length, this is the width, and this thing will be the height, and you close the flaps.
Okay.
Okay. Okay. So what will be the length, width, and height?
Of the whole box, right?
So like what will be this thing, this dimension, this length and width and height, and try to find out length, width and height in terms of x.
Okay. So length will probably be 12 minus 2x
What minus 2x?
or 24 minus 2x.
Yes, 24 minus 2x. That's good. We haven't used this information yet.
Mm-hmm.
Okay. And width?
Width will also be 24 minus 2x.
Yes, very good.
And height will be just x? No.
Yes.
Oh, really?
Yes, yes.
Okay.
Because the square has side x, so all sides are x.
Okay,
So
okay.
height is also x. Okay, so we have length, width, and height. So we'll have our volume function. So length, width times height, so 24 minus 2x. We have two of those. So
Mm-hmm.
squared times height, which is x. And we have our volume function that we need to maximize in terms of only one variable. So we can find out dv over dx.
Mm-hmm.
Okay, can you find out the derivative?
2 times 24 minus 2x times
Hmm.
uh just negative 2.
Hmm. And so you'll have to do product rule. So times x.
Oh, I didn't see the times x. Sorry, I thought that was something else. Okay.
What you can
Uh,
also do, you can expand 24 minus 2x whole square
uh-huh.
and then that times x. And then you can take the derivative. I think that will be easier, but this is also
Okay.
fine.
Okay. And then it would be plus 24 minus 2x the whole squared, right?
Hmm.
Okay.
Okay, so now we can simplify everything. 2 times negative 2, that will be negative 4x. Negative 4x times 24 minus 2x plus 24 minus 2x whole square.
Okay.
Okay, so now you can distribute negative 4. Negative 4 times 24, 96. So negative 96x plus 8x square, and 24 minus 2x whole square will be 24 times 24 is 576 minus 2ab
Mm-hmm.
times 24 times 2, that is 96. So 96x plus 2x whole square, so 4x square. So 8x square plus 4x square becomes 12x square minus 96 minus 96,
Mm-hmm.
192 minus 192x plus 576 is equal to 0. And we'll have to solve this quadratic.
Okay.
Can you factor out something?
Um, I think maybe definitely something bigger than two, but
Mhm.
um
So,
192, right?
I mean, can you factor out something from the three terms? You have three
I think
terms.
12 you can.
Yes. First, we should check always whatever is the leading coefficient. Let's see if we can factor out 12. 192 is it divisible by 12?
Yes.
It is. And then
16.
570,
16 and 48.
16 and 48. So we'll get x square minus 16x plus 48 equals to 0.
Mm-hmm.
And then factors of 48
Oh, so minus 12 and minus 4.
minus 12 minus 4, x minus 12, x minus 4. So x is equal to 12 or 4. Now we
Mm-hmm.
have two candidates, 12 and 4
Mm-hmm.
candidates. We need to check which of these will be points of maxima and minima.
Mm-hmm.
So we can do the sign analysis or we can do the double derivative test.
Okay.
This time we have three intervals to check.
Mm-hmm.
Okay, what was ds over dx? Oh, ds over dx is just this quadratic equation only. Okay, now this one is easy. We can take any point less than 4. Let's take 0. And at 0, you have to check the sign of this expression. I think that will be positive.
Mm-hmm.
0 minus 12 is negative. 0 minus 4 is negative. Negative times negative will be positive. So this entire interval is positive. Between 4 and 12, if we take, let's take 5, 6, 7, 8, 10. So 10 minus 12 will be negative and 10 minus 4 will be positive. So ultimately it will be negative. And something greater than 12, you can take 20. So then again, it will be positive. So
Okay.
positive, negative, positive. That means this is a point of maxima. This is a point of minima. So that means V. Oh, I was saying ds over dx. This is dv over dx, sine of dv over dx. So the volume will be maximum when x is equal to 4.
4. Yeah.
What happens? Yeah, when x is equal to 4. And that's the answer of the first part. What should be the side of the square to be cut off to have maximum volume? So
2.
we, no, 4, we found 4, right?
Oh, yes, yes, sorry.
So these square pieces that we are cutting, these
Mm-hmm.
should be of 4 length.
Mm-hmm.
And what will be the maximum volume? So maximum volume is, so this will be maximum volume.
Mm-hmm.
Here we just have to put x is equal to 4 into this expression. That
Okay.
is the maximum volume. 24 minus 2 times 4 whole square times 4. Okay. Find the shortest distance from a parabola or any curve. Find the shortest distance of a point
Yes.
0, comma c from the parabola y is equal to x square And it's also given that C is between
Mm-hmm.
0 and 5.
Okay.
Okay. So we have this point 0 comma C and the parabola y equals to x square. Y equals x square is an upward opening parabola. Split this. And a point 0 comma C is a very special point because it will lie on the y-axis, right?
Mm-hmm.
So we have a random point. It could be here, 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 depending on the value of C.
Mm-hmm.
We need to find out that value of C. That means that which will have the shortest distance from this parabola. Like if you take this point, its distance is this. If you take this point, the distance is this. We always take the perpendicular distance.
Okay.
If you take this point, this distance is this. Okay.
Mm-hmm.
So let's say that this is the point with the shortest distance. It's 0 comma C. And any point on the parabola will be of the form.
Y equals x
Hmm.
squared.
So the coordinates will be x comma x squared,
Mm-hmm.
x comma x squared. Okay, now write the quantity that you need to optimize.
Okay. So that would be the point. See?
See?
No.
No, no, no.
No, 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 no.
We need to minimize the distance between these 2 points.
So the distance.
Hmm. We need to find the shortest distance
Mm-hmm.
of a point 0 comma C. So this is the point 0 comma C from the parabola. Let's say the point on the parabola. First, say that this point is x comma y.
Okay.
Any point on the parabola. Let's say it is x comma y. And we have the relationship between x and y. This is the relationship. So it's okay.
Mm-hmm.
We need to minimize this distance. So that's the quantity that we need to optimize, distance
Okay.
between A and B.
Mm-hmm.
So can you find out the distance using the distance formula?
Yes, if I remember. Okay. So I think it's square root of
Hmm.
y2 minus y1.
Hmm. So C minus Y
Mm-hmm. Plus x2 minus x.
whole
The
square.
whole squared. Yes, yes.
Then 0 minus x whole square. Okay. And whenever you have square root, you can always take a square, d square, so that the square root disappears. And so you have c minus y whole square plus 0 minus x is negative x square will be x squared.
Mm-hmm.
Okay. So we know the relationship between x and y. Y
Mm-hmm.
is equal to x squared. So
Mm-hmm.
c minus y is equal to x squared. So x squared whole square plus x squared.
Mm-hmm.
So that is your d square.
Yes.
Okay. Okay. And we can simplify this. So c square minus 2c x square plus x raised to 4 plus x square. Okay.
Mm-hmm.
Okay. Now you can factor out x square.
Yes.
Okay. So if you factor out from here, if you factor out minus x square, you get 2c minus 1 and you have a plus x raised to 4. Okay.
Mm-hmm.
So that is your d square. Now let's find out its derivative. Let's say that let's give this quantity a name, anything that you want. Small
Okay.
d used, small d. So we will find out derivative of this quantity. Okay, d by dx of small d. Okay, so this will be derivative of negative x square will be negative 2x times 2c minus 1
Mm-hmm.
plus 4x cubed. Just give
Yes.
me 1 second. I have to
Okay.
send a reminder to my next student. She hasn't joined yet, so I'll just send her a reminder.
Okay, okay. I was wondering.
Yeah, done. Okay.
4x cubed. Okay.
Hmm. Okay, so for minimum or maximum value, this should be equal to 0.
Yes.
Let's put it equal to 0. Hmm. Now, if you put it equal to 0, you can factor out an x. You can also factor out 2. So
Mm-hmm.
2x, factor it out. This time, I think we will have good. So if you factor out 2x, you'll get negative of 2c minus 1
Yeah.
plus
Oh,
2x.
okay.
So this factor, either this factor should be equal to 0 or this factor should be equal to 0. So
Okay.
from the first factor, 2x is equal to 0. That means x is equal to 0. That is one candidate.
Mm-hmm.
And from the second factor, 2x squared should be equal to
Uh-huh.
2c minus 1. And from here, x squared is equal to 2c minus 1 over 2. So x will be equal to plus or minus square root of 2c minus 1 over 2. So we have three candidates, 0 and
And
pos.
plus or minus all of that.
Yeah.
Okay.
Now here it will be very difficult to do the sign
And
analysis.
analysis. Yeah.
Okay, so I think that, in this case, the people who will be grading your test, let's say you get the, if you get it in an MCQ, it doesn't matter. You can do any test,
Yes.
sign analysis or double derivative. If you get this in FRQ, you will be graded for each step.
Mm-hmm.
So, it, and the person who will be checking your solutions, that will be not your school teacher. And
Yes.
for it will not matter if you use double derivative test or sign analysis. And
Okay.
I also think that your teacher said that to use sign analysis test because probably at that time I think you did not do double derivative test. That's why she was saying to do
In
sign.
the past FRQs that she's been giving us,
Mhm.
she did encourage to do that, and if we don't write it down, she'll dock points. Because she said if there is no sign analysis shown, then there's no evidence as to where you got the answer from. So
Where you got the what?
where you got the answer from in certain types of questions, but yeah,
Oh, okay.
yeah,
I think you can ask her that, why, I mean, is it okay to use the double derivative test?
yeah.
You can ask
Okay.
the teacher. But in your AP exam, you can definitely use double derivative test. So we need to find out the second derivative of this quantity, d2 of, let's call it z, d2z dx squared. Okay, so its double derivative will be all of the constants, negative 2 and 2c minus 1 plus 12x squared.
Mm-hmm.
Okay, so we need to check the sign of this quantity at these points.